Hello everyone, welcome to SCI-EASE. In the last video, we discussed about the plane mirror. And in this video, I'm going to explain spherical mirrors. First, what do you mean by spherical mirrors? The reflecting surface of the spherical mirror, when it is curved, okay, the reflecting surface of the mirror is when curved inwards or outwards, then it is known as a spherical mirror. And spherical mirrors, they are of two types. First is concave mirror and second is convex mirror. Now, what are concave mirrors? The spherical mirrors whose reflecting surface is curved inwards like this, whose reflecting surface is curved inwards, then it is known as the concave mirror. And when reflecting surface is curved outward like this, then it is called the convex mirror. The thing will become more clear by taking the spoon. Okay, this is a spoon. If the reflecting surface is like this, inwards, then it is the concave mirror. And when the reflecting surface that is curved outwards and here the reflection that will take place, then it is known as convex mirror. Okay, so like this is the when reflection that takes place from here, then it is concave mirror. And when the reflection takes place here, then it is the convex mirror. I think the two terms, they are clear to all of you. By taking the spoon also, I have told you what are the reflecting surfaces of these two mirrors. Okay? And the other side of the mirror, that is black, that is shaded. That is shaded. Okay? Now, before drawing the images formed by these concave or the convex mirrors, we should understand few terms which are involved. So, I will discuss all these terms one by one. Now, see this diagram. I have told you that this is the concave mirror and this is the reflecting part of the mirror. Now, center of this reflecting part, center of the reflecting part, that is known as pole. That is known as pole of a concave mirror, and this is also the pole of the convex mirror. Okay? And it is denoted by P. Now you know this reflecting surface that has a sphere. Okay? And the center of this sphere of which the reflecting surface that forms, that is known as center of curvature. That is known as center of curvature. And it is denoted by C. And here, this is the center of curvature of the convex mirror. I must tell you that center of curvature is not on the reflecting surface. Center of curvature is either in front of the reflecting surface. It is in front of the reflecting surface in case of concave mirror. And it is behind the reflecting surface in the reflecting surface in case of the convex mirror. Okay, it is behind. So, C is the center of the curvature. Now, next term that I'm going to explain, that is the principal axis. The line passing through the center of curvature and the pole. Okay, the line passing through center of curvature and the pole is known as principal axis. This is known as principal axis, and this line is normal to the pole. In the same way, this line which passes through pole, center of curvature, that is known as principal axis in case of convex mirror. Now next is radius of curvature. Now this is the full diameter, okay? This is a full diameter. It is the diameter of the sphere. So the distance between center C, or you can say center of curvature, and the pole, that is known as radius of curvature. It is known as radius of curvature, denoted by R, capital R. Okay, in the same way, this is the distance between the center of curvature and the pole. Here, center of curvature is behind the reflecting surface. So, this is the radius of curvature of the convex mirror. So, I have told you about pole, center of curvature, principal axis, and radius of curvature. Now, next, I want to tell you two more terms. Now, when we draw, or you can say the rays of light when parallel to the principal axis, when they fall on the reflecting surface, okay? Suppose they should be straight, parallel to the principal. When they will reflect, they will meet at a point. Reflect, this will reflect here, this will reflect here, this will reflect here, and this will reflect here. This will reflect here, and it will meet at one point. At this point, what is this point known as? This point is known as focal point. Okay, this is known as focal point. Here in this case, what will be the case? Here, these are the lines parallel to the principal axis. They will come, this will go here, and this will come here. Again, here, and this will come here. Okay, then this is the direction, this is the direction, and they all will meet at one point behind the reflecting surface, and this point is known as focal point, denoted by capital F. Okay, so during the ray diagrams, when we will draw, you should know that the rays parallel to the principal axis, they will meet at one point known as a focal point. I want to tell you one thing, that concave mirrors are the converging mirrors. Here they will converge, these rays will converge, they will meet at one point. And this convex mirror, that is a diverging mirror. The thing will become more clear when I will tell you one activity. We shouldn't look at the sun directly, or when the rays, they reflect and they will meet at one point, and we shouldn't see that point also, because they will damage our eyes. Okay, so For this, we will perform one activity. You take the concave lens, okay? You take the concave lens and put it in the direction of, place it in the direction of the sun. When the rays, they will fall on that concave mirror, they will be reflected and they will meet at one point. So how we will take that point? We will take one paper and we will place at such a place that the bright and sharp image of the sun that is formed on that paper. Now what you will observe? That smoke will start coming, or that paper that will burn, smoke will start coming because the heat of the sun that is converging at one point. And after some time, what will you observe? That the paper will catch fire. Sun is a very hot source of energy. So the rays, they will converge at that point. And that point where the rays, they are converging, that is known as the focal point, or you can say focus of the mirror. Okay. Now, 5 terms we have done. Now the 6th term, that is the focal length. So what is the focal length? The distance between pole and F. The distance between pole and F, I will draw with black pen here. That is, it is the focal point. Okay, this is the focal length. This is the focal length. Okay, and it is denoted by small f. Distance between focus F and pole, that is known as focal length denoted by small f. Okay. There is one relationship between the radius of curvature and the focal length. Okay, and we should take the mirrors which have small apertures, and in that case R is equal to 2f. R is equal to 2f, that is radius of curvature, that is twice the focal length of that mirror. Okay, so I think the things are clear to all of you. We have done what spherical mirrors are. If the surface of the mirror is curved inwards, or you can say reflecting surface of the mirror is curved inward, then it is known as concave mirror. If it is curved outwards, then it is known as convex mirror. Then I have told you about some of the terms. Okay, pole is the center of the reflecting mirror. Okay, it is the center of and denoted by P. This is center of the sphere, that is known as the center of the curvature. In case of concave mirror, it is in front of the reflecting surface, and in case of convex mirror, it is behind the reflecting surface. Okay, then I have told you about the principal axis, the line passing through center of curvature and pole, and which is normal to the pole. It is known as principal axis. And the next is radius of curvature, the distance between the center of the curvature and the pole, that is known as radius of curvature. The next term I have told you about the focus. Okay. So this is when the rays parallel to the principal axis fall on the reflecting surface, they will meet at one point which is known as focus. Okay, which is known as focus, and the distance between F and P, it is known as focal length. And I have told you that concave mirrors, they are the converging mirrors, and convex mirrors, they are the diverging mirrors. So with this, my topic that is finished. I will come in the next video and take up another topic of this chapter. Till then, thank you very much.